The last type of equation we're going to solve this week are the rational equations. So these are not quite proportions because there's usually more than just the two fractions that are equal to each other. Sometimes there's a third fraction, or sometimes there's another number, like this number, big number 10 here, that is not a fraction yet, that kind of prevents you from doing the cross multiplying right in the beginning. So we're going to follow these steps. The very first step you're going to do is to create a common denominator for all of the fractions that are in that problem. So if we look at the very first example, the first fraction has x minus 2. Second fraction has x minus 2, but the 10 does not. Right now, the 10 is over a 1 and has a denominator of 1. So the first thing we're going to do is actually create a common denominator for that 10. Since the other fractions have x minus 2, I'm going to multiply the top and bottom of this fraction by x minus 2. Here's what my equation is going to look like now. So what I did was distribute 10 times x and 10 times negative 2 to get 10x minus 20 for that new fraction numerator. Now, every single fraction has the exact same denominator. That's what we want to see, everything identical on the bottom. Then the really easy step, what we're going to do is we're going to ignore those denominators and just use the tops of those fractions to make the equation that we're going to solve. So here, I'm just going to look at the very, very top. Ignore the fact that we got x minus 2 on the bottom. Just ignore it. And the new equation we have on the top here is x plus 4 is equal to 10x minus 20. This is the equation we're going to solve. This is the equation that's going to help us find the answers that we're going to do. So now we're on to step 3. We're going to use the steps from part A, which is distributing, combining like terms, and we're going to go from there. So in this case, I think I'm going to subtract x from both sides and add 20 to combine the like terms. So we're going to get 24 is equal to 9x. And then I'm going to divide by the 9. And 24 does not divide by 9 evenly, but we can reduce that fraction by a 3. So we'll get 8/3 is equal to our x value. So let's walk through that steps again with a couple more problems. First step is to create a common denominator for all fractions. So in this next example, we have x minus 8. This 1 has a denominator of 1. And the last one is x minus 8. So the fraction in the middle, 1 over 1, that needs to get a common denominator. So I'm going to multiply the top by x minus 8 and the bottom by x minus 8. Now here's the place where you want to be very careful. This is a subtraction problem, so there is a little bit of distribution that's going to happen when we use all of the top pieces. So we're going to start off with the very first fraction, which is a 1. We are going to subtract, because we got a subtraction sign here, the top, which is x minus 8. And I'm going to put that in parentheses because both of those items need to be subtracted. Both x and negative 8 need to be subtracted. On the other side, we get that 7. So now we're going to follow all the same rules we had in part A, distribute, combine like terms, solve for x. So we're going to distribute that negative. On the right, I have a couple of like terms that I can combine. And then I can subtract that 9. And divide by the negative to get my final answer. Two more problems. Again, the very first step is to get a common denominator for everything. So I have a denominator of 5x, another denominator of 5x, so those are already the same. Over here, this is 1 over 1. So we're going to make sure that last fraction, it has a 5x as a denominator. So there's the equation with every single fraction having a 5x as the denominator. So what you're going to solve is you're literally going to take everything from the top, the equation that's made from the top. X minus 4 equals 1 plus 5x. So I'm going to subtract x over. I'm also going to subtract the 1. And then I'm going to divide by 4. Now in the last example, we have 3 fractions, 6x squared, a 2x, and a 6x squared. So 2 of these fractions are the same already. The one in the middle is not. So we have to think about how we're going to change this into the other ones. Well, this one has a 2, and the other denominators have a 6. So I can multiply by a 3 to make that happen. Make sure that's multiplied. And the one in the middle is x to the first, but the other ones are x squared. So I'm going to need 1 more x to change that x into that 2x into a 6x squared. So what does all of this look like? So that's what all the fractions look like when they all have a common denominator. Once they all have that common denominator, and that's the important step, is making sure they're all together and all identical, you can now take the top part and make the equation out of that. 1 is equal to 3x plus 7. So we'll subtract 7. We'll divide by the 3. And we have our answer. Now, some of you may look at these problems and say, well, can't I do a little bit of cross multiplying? So for example, back in this very first one, these 2 fractions are common denominators. You can add them together and you might be able to cross multiply. That is a completely valid way of solving this problem. In more difficult problems, however, it makes more work for yourself. When you cross multiply and use the proportion, you might end up with some quadratics or even some cubics, and you get to end up with some equations that require a lot more factoring to be able to solve it than these examples in here. So my recommendation for these new fraction problems is to make sure every single fraction has the same denominator first. And then you can take the shortcut of just taking an equation out of the numerators.